Today we're going to learn how to prove a quadrilateral is a parallelogram using coordinate methods. So instead of getting a picture, they're going to give you 4 points on a graph and you need to determine if the quadrilateral is a parallelogram. So today we're going to use, again, the 5 methods to prove a quadrilateral is a parallelogram. And the first one is opposite sides of a parallelogram are parallel. So if we look at this diagram in a picture, for them to determine if they're parallel, they need to have the arrow. So we need to know that BC is parallel to AD and BA is parallel to CD. And the arrows indicate that the opposite sides are parallel. So we mark the parallel sides of the parallelogram above. But instead, today they're going to give us a graph, or they're going to give us 4 points, and we're going to have to figure out if those 4 points form a quadrilateral. And in this problem, they want us to prove it, showing that the opposite sides of a quadrilateral are parallel. So for this problem, they give us these 4 points, A, B, C, D, and we want to figure out if both pairs of opposite sides are parallel. So in order to determine if 2 sides are parallel or 2 lines are parallel, we know they need to have the same slope. So we need to check that the opposite sides have the same slope. So I'm going to plot the 4 points, and I'm going to label them. So this is A, this is B, C, and then we have D. And then if I connect my 4 points, then I have a quadrilateral. And we need to figure out if this quadrilateral is a parallelogram using opposite sides parallel. So we need to find the slope of all the sides. So I need the slope of AB, of BC, DC, and AD. So the slope of all the sides. So there's 2 ways you can use the slope formula, or since we have on a graph, we can count it. So the slope of AB, we goes up 1 over 2, so it's 1/2. The slope of BC, we go down 1, 2, 3, 4, and over 3, so the slope is -4/3. DC, from D to C, we rise over 1, we go up 1 over 2, so it's 1/2. And then AD, we go down 1, 2, 3, 4 over 3, so the slope is -4/3. If you wanted to do it algebraically, we could always do our slope formula. So for AB, we would just do 5 minus 4, y2 minus y1 over 3 minus 1, and that would give us 1 over 2. So you can do it algebraically for each set of points as well. It doesn't matter, but you need to show the slope of every single line on this quadrilateral, or every single segment. So for this quadrilateral, if we look at it, A, B, and D, C are across from each other, so they have the same slope, so they're parallel. So, and then AD and BC are across from each other, and they have the same slope, so they're parallel as well. So if it asks, is this a parallelogram, we would say ABCD is a parallelogram because opposite sides have the same slope and therefore are parallel. So for this method, you need to make sure that you show the slope of every single segment on the parallelogram or on the quadrilateral, and then notice that if they have the opposite sides have the same slope, then it is a parallelogram. The second reason we looked at was opposite sides of a parallelogram are congruent. So if ABCD is a parallelogram, then AB has to be congruent to CD, and BC has to be congruent to DA. So we want to mark the congruent sides. So I'm going to mark AB and CD with 1 mark and BC and AD with 2 marks. So for this one, in order to prove things are congruent, we need to know the opposite sides are equal or have the same length. And then to determine the length, we find the distance between all the points. So I'm going to plot our 4 points again. Right. And then if you look at this, on your packet, point D is different. So please change your point D to -2, 1. And then plot that new point. So we have this. If we look at it, it's pretty obvious that it is a parallelogram. But again, we need to prove it. So our goal for these are we're going to prove that this is a parallelogram based on the fact that both pairs of an opposite sides of a quadrilateral are congruent. So we need to show that DC is congruent to AB and AD is congruent to BC. So in order to do that, we need to find the distance or the length of each side. So we need to find the length of DC, CB, AB, and DA. Now, DC and AB, since it's a horizontal line, we can just count. So DC is 1, 2, 3, 4, 5. So the length of DC is 5 units. And AB is 1, 2, 3, 4, 5. So we have one opposite side congruent. So now we know that DC is congruent to AB since they're both 5. But CB and DA, we have to use either the distance formula or Pythagorean theorem. So I'm going to use the graph. If we make a triangle, a right triangle, we count our sides. So we have the one side is 3, the other one is 1. So I'm going to do 3 squared plus 1 squared. And we're going to end up taking the square root of it to get the length of the side. So we have 9 plus 1, so we have the square root of 10. And you can make that a decimal or you can leave it like that. It doesn't really matter. Then, so that was for DA actually, I just did. And then if we do CB over here, if we look, it goes over 1 up 3. So our two sides are 3 and 1, so I already have that. And then we do the A squared plus B squared, and we have to take the square root because it's equal to C squared. So both of those sides are square root of 10. So now we know CB is congruent to DA. So we know that both pairs of opposite sides are congruent, so ABCD is a parallelogram. Okay, because DC is congruent to AB and CB is congruent to DA. So that's our second coordinate proof. Okay. The third one, which might be the hardest one, way to prove a quadrilateral is a parallelogram is the diagonals of a parallelogram bisect each other. So in this parallelogram, in order for it to be one, BE would have to be congruent to ED, so I'm going to mark the lengths of each diagonal. And then AE would have to be congruent to EC. So if we come to our diagram again and we plot our 5 points, we have 3, -5 for M, 0, 2 for N, 4, 1, or 4, -1. And then 7, -8 for T. Okay. So this is my quadrilateral. And we need to prove that the diagonals bisect each other. So I'm going to draw my diagonals in. So remember, our diagonals go from the points across from each other. So one of them would be from N to T, and the other one would be from M to P. So So we need to prove that the diagonals bisect each other for this to be a parallelogram. So we need to show, our goal is we need to show that N, and I'm going to call the point where they intersect O. You can call it any point you want, but NO is congruent to TO, and we need to show that MO is congruent to PO. And if they're not, then this is not a parallelogram. So in order to do that, we need to find the distance from N to O. In order to find the distance from N to O, we need to know what point O is. So we know O is the midpoint of either NT or MP. So to find O, we find the midpoint between either NT or PM. It doesn't matter which one because they're going to give you the same point because it's the midpoint of both. So for this, if I use my midpoint formula, I'll just do between NT. So for the midpoint of NT, it would be, we add our x's, so 0 plus 7 over 2, and then we add our y's, so 2 plus negative 8 over 2. And so the first one we get 3.5, and then the second one we get negative 3, which, check on your graph, it looks about right, 3.5, negative 3. So that's our point O. So now we're going to find the distance between N and O. Now, this is a little bit harder to do on the graph and make the triangle because there's a lot of lines, and because it has a decimal for the x-coordinate, so we can also use our distance formula. So I'm going to use our distance formula for this one, but you can use your graph. You just have to know that, like, when you do your change in x, you're going from 0 to 3.5 to figure out that distance. So for this, the distance formula, we take the square root of x1 minus x2. So I'm going to do 0 minus 3.5 squared plus, and then it's y2 minus y1. So I'm going to do 2 minus negative 3 squared. And that gives us negative 3.5 squared plus 5 squared. And if we simplify that, we get the square root, or we get 6.103 if we square them and take the square root. Make sure that when you square negative 3.5, you get a positive. So that's our one diagonal. Then we also have to find TO, and that should be the same distance. So I'm going to use my distance formula from that. So from T, it's 7 minus 3.5 squared plus, and then negative 8 minus negative 3 squared. And we're going to simplify it and put in our calculator. So 7 minus 3.5 again gives us 3.5 squared plus negative 8 minus negative 3 gives us negative 5 squared. And if you simplify that and take the square root, you get 6.103. So we do know now that NO is congruent to TO. So we have a diagonal bisected, but we have to show the other one is. So we have to find the distance from M to O, and then we also have to find the distance from P to O. So if we look at our coordinates again, M is 3, negative 5, so I'm going to do the square root of our x, 3 minus our same midpoint O, 3.5 squared plus, and then the change in our y's. And we're going to simplify that, so we get negative 0.5 squared plus negative 2 squared, and if we simplify that, we get 2.06. And then we need, the last one we need is the distance from P to O. So we're going to do the square root. Our coordinates for P are 4, negative 1. So I'm going to do 4 minus 3.5 squared plus negative 1 minus negative 3 squared. And then that gives us 0.5 squared plus 2 squared, and that should give us the 2.06. And so we can also see that MO is congruent to PO. So since we know those two things, quadrilateral NTMP, and actually we need to fix that. So when we name the quadrilateral, we have to start at one corner and either go clockwise or counterclockwise around. So for this one, we can name it NPTM. This quadrilateral is a parallelogram because NO is congruent to TO and MO is congruent to PO. And that means that therefore the diagonals are bisected, which makes it a parallelogram. Okay. So that was our third method to proving a quadrilateral is a parallelogram, which is probably the longest one. The fourth method is that we can have one pair of opposite sides of a quadrilateral both congruent and parallel. So in our first one, they said AB is congruent to CD and AB is parallel to CD. So that proves it's a quadrilateral, or it could be the other way, that BC is congruent to AD and BC is parallel to AD. So for this example, we have these 4 points R, S, T, U, and we want to prove that that's a parallelogram based on opposite sides being congruent and parallel. So I'm going to plot our 5 points. And I'm going to have to go off the graph for this one. Okay, so I have my 5 points, and we want to prove that this is a parallelogram using this method. One pair of opposite sides is both parallel and congruent. Now you can pick either opposite side. It doesn't matter which one. And one in this case is not easier than the other. So I guess we can just do ST and RU. So we want to prove those are both parallel and congruent. So to prove ST is parallel to RU, we need to find the slopes. So if we look at slope of RU, if we do on our graph again, we go up 2 and then over 1, 2, 3, 4, 5, 6. So it's 2 over 6, which reduces to 1/3. And then the slope of ST, we go up 1 and then it's 1 more, 2, and then 1, 2, 3, 4 over 6. So it's 2 over 6, which is 1/3. Again, you can use the slope formula if you prefer. So those slopes are equal, so we know that they're parallel. But we also have to prove ST is congruent to RU. So we need to find the distance. So if we use these, we make our triangle. If we do that instead of the distance formula, we can use our Pythagorean theorem. So I make my triangle. We count our blocks. So we go over 1, 2, 3, 4, 5, 6. So we're going to do 6 squared plus, and then up 2. 2 squared is equal to C squared, which is RU. And so then we get 36 plus 4 is equal to C squared, and C then is the square root of 40. And then we have to do ST, so I'm going to make my triangle again for ST. We go up 2. So this was RU. And now we're doing ST, so we go up 2, so it's going to be 2 squared plus and over 6 6 squared is equal to c squared. So we get 4 plus 36 is equal to c squared. And then again, we get c is the square root of 40. So we know that s, or ru, equals the square root of 40, and st equals the square root of 40. So therefore, RSTU is a parallelogram because ST is congruent to RU and ST is parallel to RU. Okay. So therefore we know one pair of opposite sides is both congruent and parallel. And you need to make sure that you show the slope for both and the distance for both. Okay. And then the last method, opposite angles of a parallelogram are congruent. We won't be given points. We'll instead be given expressions for each angle, and then we have to find the value of x. So we know that for opposite angles, angle A would be congruent to C, and B is congruent to D. So we need to see if this is a parallelogram, and we have the 4 angles in the parallelogram. So if I just draw a diagram, we have A, B, C, D. A is 3x plus 18, B is 4x minus 4, C is 2x plus 32, and D is 3x plus 26. And all we know is that it's a quadrilateral. So we're trying to prove this is a parallelogram. So to do that, we need to realize that the 4 angles in a quadrilateral add up to 360. So we need to find x by adding our 4 angles. Up to 360 because all quadrilaterals angles add up to 360. And so if we add our like terms, we get 12x plus 72 is 360. And then if we solve it, we're going to get x is 24. To know if the angles across from each other are equal, we have to plug them back in. So angle A, we're going to plug 24 in. And when we do that, we get 90. And then angle B, we're going to plug in 24. And when we do that, we get 92. And then angle C, if we plug that in, we get 2 times 24 plus 32, and that gives us 80. And angle D is 3 times 24 plus 26, and that gives us 98. So if we look at this, our opposite angles according to our diagram are A and C. So if we look at angle A and C, angle A does not equal angle C, and angle B does not equal angle D. Okay, therefore I'm going to use the symbol A, B, C, D is not a parallelogram. Okay. So that's proving that it's not a parallelogram. So for it to be a parallelogram, when we plug them back in, A and C would have to give us the same number, and B and D would have to give us the same measure. So those are the 5 ways to prove them using coordinate methods or algebraic methods. And those are your notes for today.